The most common evaluation metric for a classifier is something that we call the confusion matrix. To simplify the introduction of the confusion matrix, let's just think about a two-class or binary classification problem. And as you can see, the output value has a cardinality of 2. Those values are typically identified by 0 or 1 or true or false. We will use to introduce the confusion matrix the concept of true or false, or positive or negative. Now, in this particular case of a binary classifier, the confusion matrix will be a 2 by 2 matrix, which will contain the classes and the outputs of those classes in the 4 different areas. So, for example, for a class that should be positive, for a record for which the output should be positive, and the actual prediction is positive, is true, we call that a true positive. So it's a correctly identified positive or true output. If instead the prediction for that same row would be negative, that would be called a false positive. And again, along the same logic, we have the false negatives and then we have the true negatives. So basically, every single prediction the model does falls under one of the cells in this matrix. And those in themselves, you might think, are quite interesting, but what is interesting is the set of evaluation metrics that we can infer from this particular matrix. One of the metrics that is commonly used is accuracy, which is basically the proportion of correct predictions. So you add the true positives with the true negatives, and then you divide to the number of all cases, and that will give you the accuracy. The next one is precision. Precision is the division between the true positives and the sum of true positives and false positives, which is actually, if you think about it, is the proportion of positive cases that were correctly identified. Next is recall, where we split the number of true positives to the sum of true positives and false negatives, which is, again, if you think about it, the proportion of actual positive cases that were correctly identified. And lastly, a more complex metric is the F1 score, which does nothing else but kind of measuring the balance between precision and recall. And obviously there are many more types of metrics that you can derive from the confusion matrix. One interesting exercise that I would propose to you, and I will leave it as an exercise for you, is the following problem. Think about accuracy, precision, and recall. The interesting property is that none of these independently are enough to provide an accurate measurement of the metrics for classification. And in real life, they are always kind of used in pairs. So you need to take either accuracy and precision or accuracy and recall to get a complete image of your classification algorithm. So I encourage you to think about this and try to identify why is that happening.